Okay, you want the camera is on. Do you want it to be on? Because it's at a very weird angle. Okay. All right. Ananya, can you hear me?
Yes.
All right. Good. So, all right. So, what are your names?
My name is Balaji.
Bala?
Balaji.
Balaji. Okay. Your name? Hmm?
Chitesh.
Chitesh. Okay. You guys, when did you guys join? Today is your first day.
Actually, he was a batch from previously.
Okay.
But the timings were not right for me. So
Okay. Okay. And you?
First
First class. How did you know of this advertisements? Okay, fine. All right. So I'll be teaching physics for you all. My name is Flanish D'Souza. I'm a researcher at IIT Madras. I work in high energy laser physics. Okay. Any of you interested in physics or research? Not that much. Okay.
when it comes to adding agent, what is your
Adding?
I game developers.
Hmm?
I do game development.
Okay. Okay.
Only like that.
Light and all of that, huh? Light, it's how something moves, how it should accelerate.
When it comes to that, just go over it.
Google it, get it done, and done. Finish. All right. Good. So today, and see, I'll be following your textbook that is given to you. Okay. Don't open your textbook. It's okay if you don't take notes, unless I tell you. But the main aim is you should listen to what I say or what is being explained. So once the concept you hear properly and it sits inside your head, second time when you read it, you will be able to understand what it is. Okay? Because making notes, everything is there. Okay? Unless you're somebody who believes in writing and learning or something, you're somebody who takes notes, it's in your habit, you can do so. Okay? Feel free. Is that okay? You look confused. It's fine. Okay. If you want to, you can, but I prefer that you listen to certain things. And this first chapter is very theoretical. At least the initial discussions, we are going to define a lot of things and all of that. So I'm not a big fan of this, but it is what it is. Okay. So the unit starts off with talking about some two concepts. One is called measurements and the second one is called units. Okay. So what is a measurement and what is a unit? Scale of something. Okay. Hmm. The way you express it. Okay. So it is defined as unit is defined as a standard of measurement. Okay, and it's so basically the idea is simple. I have a particular quantity and I want to quantify that quantity. Okay, for example, now when if there is a person, the person has many different qualities, correct? Now if I want to describe a particular person, I can describe his various different qualities. If I want to talk about his fitness, maybe I will talk about how fast he can run, maybe. Or I can talk about the person's weight, maybe. They are his physical properties. Or I can talk about his height. That gives a physical impression of what is the physical property of the person. Correct? If I want to talk about his emotional state, maybe I will talk about how mature he is or he or she is. If I want to talk about their gender, that is another type of physical quantity, correct? Another type of quality. I'll talk about maybe is a male or a female. You know. So there are different types of qualities that anything can have. And just knowing this quality is not enough. If I want to tell somebody that I want something of this sort, I need to be able to explain that quality in a measurable way. Getting it? If you just tell somebody, okay, how do I make biryani? Take some rice. The guy is not going to understand how much rice to take. You're going to have to tell 1 cup of rice, 2 cups of rice. Is that clear? A particular quantity, a measurable quantity you need so that you can explain things in an effective way. Correct? And so that you can describe the quality of a particular object. Okay. So basically a unit is a physical quantity which is used to define a particular measurement. Okay. And what is a measurement? A measurement, it's basically, it's something, so the way these people have described is, they have said that a measurement is any physical quantity, measurement of a physical quantity is the comparison of the quantity with its unit. Meaning, my unit is 5 kg. Now I am going to compare how many kgs of something I have. So I will tell, okay, I take a glass of rice and I don't know how many, I have the unit kg. So somebody will tell, okay, how many of these kgs do you have? So I am comparing this, I am going to say, okay, 1 kg. This looks like I have 5 of this 1 kgs. So it's kind of like you're comparing the quantity with the unit. You're getting the idea? If I say I have one small building and I have Burj Khalifa or whatever here, right? One way I can say is, if this is 1 unit, I can say I have 2 of Burj Khalifa, 2 of these buildings fit in 1 Burj Khalifa. So what I am doing here, I am comparing the quantity with the unit. Unit is 1, the measurement is multiple times of that 1 unit. Understood? Clear? Is that simple? Done. Okay. So quantities are of different types, and similarly units are also of different types. So the first type is called, actually we can discuss both simultaneously. Now for example, the first one is called fundamental quantity. Fundamental quantity. And the second one is called, very nice, derived quantity. So what is the difference? Does anybody know the difference between fundamental and derived?
Using fundamental quantities only we will derive the quantities.
Correct. So the meaning, the idea is quite simple. Some quantities are very fundamental in nature. Weight, kg. What is the height? In length, I'll talk in terms of meters. So these are fundamental. But when I tell you about derived, you will understand what fundamental is properly. Derived is, for example, if I take speed, what is speed? Speed becomes distance traveled by per unit time. So speed is not something that can be defined by itself. In order to define speed, I need to know what is my distance, what is my time. Getting it? So the quantity here is not independent. It has something that it depends on. So this kind of a quantity is called derived quantity. But the distance in this case, the quantity distance is a fundamental quantity. Obviously, there is nothing smaller than distance. And time is a fundamental quantity. Quite simple. Understood this much? Similarly, when it comes to units, we have 2 types. Fundamental and derived, same thing. For a fundamental quantity, let's say it is length. What will be its unit? Meters. Alright. Now what will be the unit of this derived quantity? Meter per second. Do you guys know these notations and all of that, right? You're comfortable with this. Meter numerator, second denominator. Alright. Fine. So now there are different types of units, there are different systems. You might have seen these Americans and all, they don't use our, we say kilometers, yes, that many kilometers away. Yes. So they say miles, they use foot, they use a different kind of a system altogether. There are different types of systems. There is CGS, centimeter gram second, FPS, which is foot pound second. There are different types of system. but the one we follow is the metric system, or it's even called the SI, okay, which stands for, it's a French word which basically goes System International Day Units, okay, or in English it just becomes System International, okay, that's all it means. SI stands for that. And under this, the reason is quite simple, that everybody around the world should be able to understand what your quantity is. Now, for example, that American is talking in terms of mile, you are talking in terms of kilometers. When you tell him I am 5 kilometers away, he is asking you where you are. You tell I am 5 kilometers away, he is not going to understand. When you ask him where you are, he says I am standing miles away or something like that. You are confused. Both of you are not able to communicate properly. So there has to be some sort of a standardization, so that people from around the world can work on things properly. And this is especially important in the manufacturing domain, because now, for example, I am making a rocket, let's say, and a lot of scientists actually face trouble in this. They go to the US and all of their measurements are in terms of inches and things like that, and we use our standard system are here, we use the metric system. So people go over there, nothing is in centimeters, nothing is in meters, everything is in inches and things like that. So things become difficult. Except USA, everybody follows the SI. All right, fine. And in SI, what we have is everything that we follow. Basically, we use the meter scale for distance. For time, we use our second. For temperature, we use Kelvin. Okay, is that clear? So all of these things, that for weight we use kgs. Okay, all of this is clear to you? So the thing is, this unit, no, initially it's very theoretical and I have to define things. That's why we are doing it this way. Maybe further when we go to different units, it will be more fun to discuss it. We can do fun activities and things like that. Okay. And there are, if you go through your textbook, there are different SI units that are described. Okay. You can open your textbook now. We'll just go through it, explaining the same, because you can go to your page number, chapter 2, it should be page number 9. Yeah, 9, go to page number 9. It's not in page number 9? We have a different page system, I think. Okay, fine. Okay. And also the thing is, some of these numericals and all come slightly later, so it becomes slightly tedious, or what do we say, slightly boring initially. Okay, no issues. I'm just going through those definitions. Because the problem is, this unit is such that it's initially only defining things. Okay, there are no numericals, there is no concept that I can just start explaining. Okay, so it basically tells you how to define fundamental units, and there are different units that are listed. For example, 1 meter. So what they did is, 1 meter, how do you define? But how do you define it? How do I define? If I take one scale and I tell any length, I'll take the first person to define a meter. He took a scale, let's say a steel scale, and he said, okay, this is, today I decide this is going to be 1 meter. Okay, and every time you want to measure 1 meter, we'll make replicas of this. He would have said something like that. But the problem is with steel, that steel can expand in heat. So that 1 meter is going to be different during the summer and it's going to be different during the winter. So what these people said is, okay, we know that distance is equal to speed by, I'm wrong. Yes. Speed is equal to, what is this? Speed is equal to distance by time. So time comes to the numerator are here and comes this. Clear? Is this clear? So what this said is, okay, what is that thing which has constant speed? Light has constant speed. So let me take some light. I'll take a laser, and and I know how to measure time. So the idea is basically how much distance does the light travel, and I know what is the speed of light, man. Roughly 2.9 10 to the power minus 8. Oh, sorry, not minus. 10 to the power 8 meter per second. So the idea is, this is its speed, and if I take 1 by 2 point that many seconds, how much distance is this going to travel? Are you getting the idea? You are not getting the idea. Speed of light 2.9 10 to the power 8 meter per second. Understood? So what does this mean? It travels 2.9 to followed by 8 zeros in 1 second. So in 1 second, how much distance will this light travel?
In 1 second it will travel 2.9
10 power minus 8 seconds. So in 1 by 2.9 10 to the power 8 of a second, how much distance will this travel? Now you are understanding?
1 by
How do I explain this? See, this is, but why have they explained it in this way? This is going to be difficult for you guys to understand. Okay. This is not the right way of explaining something. Okay. But regardless, the idea is, this many meters it travels in 1 second. They divided by the distance. That should not be the case. The textbook is wrong. Okay, they have made some error, but they said, okay, in this many, in this much period of time, how much does the light travel? So basically, what you have is the speed of light never changes. Summer or winter, day or night, it never changes. So the idea is the distance traveled by light is going to be the same in that much time, provided you can measure it properly. Okay, so I just say that I'm going to note this time thing and how far is the light going, and that is going to be my 1 meter. Does that sound fair to you? Is that understandable to you guys? Okay. And even with kilogram, the thing is, what they did was, initially they took a standard block of a material called platinum iridium alloy. Maybe for some of its physical properties, maybe it's unlike other things. If I take maybe metal, it will rust. So I'm going to lose some weight. It will evaporate. Some other material may evaporate. Some other material may decay in some other way. So they have used platinum iridium alloy, and they taken one block of it, and they said, okay, we will call this 1 kg, and that has been 1 kg ever since. All right. And if you divide this weight by thousands, I'm going to have 1 gram. Clear? So this is how you do standardizing. It's nothing you have to take something that does not really change over time and something that can be replicated in multiple places. So even there are things, I believe, where once in so many years or something, they keep changing the block. And in fact, there are museums where you can actually see that block of platinum iridium, where you can say, okay, this is the international standard of 1 kg. Understanding how when you buy vegetables, on a scale, the vegetable person is going to put a piece of metal to weigh how much, on a balance to see how much vegetable you have taken, correct? So that way there is a reference around the world for it, how much it's going to be. So similarly, things like that, and they have again, see, when they have defined a second, they have gone into the time. See, this is how it defines it. 1 second is defined as the duration of 9,192,631,770 periods of radiation corresponding to the transition between two hyperfine levels of the ground state of cesium-133 atom. I don't know why they have defined it like that. To make your life miserable, probably. Even I'm like, why are they talking about hyperfine? You guys probably don't know what hyperfine structures even are. Don't bother about it. If it's in your NCERT, you read it. If it's not, don't bother about it. Basically, something very standard. Some sort of a de-excitation happens inside an atom in hyperfine. Don't bother about it. You're so confused. Okay. In an atom, let me say, atom has a nucleus and it has electrons around it. Correct? Electrons have multiple energy levels. Okay. I can draw these energy levels like this. I can draw it like that. Here I can say the electron is in ground state. Here it has gone to the excited state. Understood? Something strange that happens in these atoms is, if I subject this kind of an atom to an electric field or a magnetic field or any kind of an electromagnetic disturbance, these energy levels kind of split up. Okay? And all of these will have the same energy, but they are called degenerate energy levels. So these structures are sometimes called hyperfine structures, and a de-excitation from here to here or some other kind of hyperfine structure to here, that is taken as the standard time of 1 second. Don't bother. Because the reason they do these things is because these things never change. If I measure the time today for this snow, and if I measure 100 years later, it will still be same quantity. So I can always call it 1 second. So if in Japan one guy is doing this, he is measuring the time, and in let's say in India one more person is doing this, they are going to get the matching results. 1 second time is not going to change for anybody. Is that clear? That's why it's called standard. Understand? It's something that never changes. Your meter is not going to change after 500 years. It's always going to be that length. We divide it into 100 centimeters and things like that. That is our thing. That's a different situation. Understand? That is a division. But that length is always going to remain constant throughout your life, throughout your children's life. Okay, there are some more definitions like that. We will not go into it. You can read it yourself. Okay, but we can talk about something that the textbook talks about in some interesting details, some interesting thing they have done. So what they are saying here is that if you want to measure from millimeter scale to a few meter scale, you can use a scale. Just scale. If I want to measure something that goes smaller than a millimeter, I use something called a vernier caliper. Okay, are you familiar with that?
Because we got a project like physics record activity called
Yeah.
calipers to measure the radius of the sphere like something.
Okay, perfect. So do you know what is the concept of least count? Okay, so least count is the minimum quantity that your measuring instrument can measure. For our scale, what is the minimum quantity? 1 millimeter. Exactly. So that is going to be 10 to the power minus 3 meters. Correct? But I cannot go beyond 1 millimeter. Can I say this length is half a millimeter? You might be able to see that it is lying between two lines. Let's say you are measuring something. It is lying between those two lines. But still you should never say it is 0.5 millimeter. Because is there a line over there? No. So how can you say? Okay? You getting it? If it's smaller than 1 millimeter, maybe you can see, oh, I can call it 0.5 millimeter. It's coming between two lines, but you should never say that. You should round off to a next number, because the minimum quantity only this guy can measure is 1 millimeter. So what we do is, to measure things that are smaller, we have instruments called vernier calipers and things like that, which have a smaller least count. They can measure things which are smaller than this. Okay, but what happens when we have things that are very enormous in size? For For example, I want to measure the distance from here to one particular planet or something like that. Okay, correct. But what they do is they use geometry and things like that in order to measure the distance. Let's say from Earth to a particular planet, we use something. There's a particular concept called the parallax method.
I will about this balance method, the first chapter of the physical world.
Okay, so do you remember anything about it?
They said like something with your hand, hide your one eye and then keep your one hand towards the heat that you are measuring. Then do the same by changing the hands. You can see that the things differ. So we can't use our hand to measure anything. So parallax method, we will do some approximation and then we will measure. For example, like 1 meter, 1 meter will convert into a larger scale or something. I didn't understand it better.
Okay, so basically the idea is simple. Do you know we have two eyes? The reason for this is, it's called parallax. Yeah, field of view, and the idea is this, that see, if I look from one eye, I will not really know how far you are. The depth effect. So when I open my other, you realize when you look at the same thing but you close one eye, you see the position slightly changes. And what that does is it tells your brain, so there are two images that are going into your brain, each from a different position. So that perspective, there is a difference in the angle from which you are viewing it, and your brain calculates the distance. Okay, that is why the concept of now our phones have more and more cameras on the back. Before it used to be just one. Now we have more, because what we do is we keep one camera at a slightly different angle so that it can resolve things in a better way. Resolution basically, what is resolution? Resolution is, let's say the word from far you can resolve this, meaning you know what is an F, you know what is a 0, you know, FOOT, you know the alphabets, you are able to resolve these as two different alphabets. But you know what happens when you come really close to it? Everything becomes blurry. You cannot say two different, you cannot make out the differences between two different things. That is called resolution. Alright. Okay. So this parallax thing with the slightly different view, it helps us resolve things in a better way. But this also has a limit. For a human being, it's about 25 centimeter. When things come closer than that, we are not able to resolve two things as two different things. We are not able to tell. It becomes blurry. Alright. So now with this parallax thing, so what they do is, see, we have a planet which is far away. This is our Earth. Okay. And now I don't know how to measure the distance between the Earth and this particular planet. So what I'll do is I'll put up two observatories, one in A, one in B. The Earth is curved, correct? And I cannot measure the distance, but I can measure the angle. I can measure the angle. Okay, that's quite easy to do. And the basic idea is that when objects are very, very far away, and I know the distance between these two particular observatories, okay, and the distance between them is B, and what I am going to say is B by D, actually what they say is, okay, B is the distance between the two, this thing, okay. So the better way to explain this is, I can, okay, are you aware of arc of a circle and things like that? The angle made by the arc and things like that. So you would be familiar that when we have a circle and there's an angle made by the arc for large distances, if this is B and this is going to be our D distance or the radius or whatever, then my formula is going to be B is equal to d theta. Let me erase this, let me write this better. Why is this not erasing? Meaning, what is B? D, I am going to drag this along this theta. You getting it? B is D times theta. In order to get B, I am going to drag my D along theta, and that's when I get my particular length B. Clear? What is the area of a circle? Pi r. And what is the circumference of the circle? 2 pi r. That is r, I am taking the radius and I am going to revolve around 2 pi. That is my theta, and that's where I get B for the entire circle, which is 2 pi r. That's my circumference. Same logic. Understanding? In order to get B, I take the distance d and I sweep it across my theta. I multiply d into theta and I get B. Say, d into theta. You multiply it. So I get B. For circumference of a circle also, you do the same thing. Okay, 2 pi r. So what are you doing? You have an r, this is your radius, and I am going to multiply it into theta. Theta is the whole angle. Here is what 2 pi? 2 pi is 360 degrees. So I am going to take r and I am going to go all around 360 degrees, and that's where I am going to get the circumference of the circle. Same logic. Here 2 pi is my theta. Theta into r. Here theta into d. Same thing. Okay, it's theta into d. Go home and think about it again. It's very simple. I think you guys got it. Yeah. So see, theta I was able to get. B I know. Will I be able to calculate the distance? It's very straightforward. Huh? Theta is going to be, see, they have instruments to do this. Hey, do you know this one? In 10th standard, you must have seen this. So the pirates and all, people who are on the sea, in order to keep them, for them to know where they are, they would have a particular instrument wherein they could look away with a particular rod, and I think there was a particular, the sun's rays or something that would hit at a particular angle, and they would, you know that thing? You know about that. So basically the idea is quite simple. There are instruments that can measure it. It's not that difficult. It's, for example, the thing is now, for example, let's say I have a flower vase. Okay. I am viewing the camera. Since you are into game design, you must be knowing. I am viewing the vase from here. I move my vase by a particular angle and I put it here and I view it from here. I know my initial position. I take one image here, first image. I know by how much angle I am moving, let's say 30 degrees. I take my final image. I know that what the final image looks like. It will look like a particular angle, no? Okay, and I know from first it was looking like a particular thing, and I moved my camera by how much degrees? 30 degrees. So what these people do is they kind of do high-end calculations on a similar logic, wherein they are only seeing the image, but using the image, final image, they are able to recalculate what is the angle between. It's beyond the scope of your education. It's fairly more complex, but you are getting the concept, right? So if I have a star, I can tell, okay, from this side this guy is seeing this face, or let's say the moon. From here I am seeing this face of the moon. From there they are seeing this face of the moon. We know what the moon looks like. So can I tell approximately what might be the angle between this picture taken and from this side taken? I know the two sides. I can kind of approximate it, right? You're getting the idea? Clear? Fair.
An approximate only.
But now they are very accurate. Now it's not approximation, it's very accurate. They use a lot of different techniques also. They, in fact, in order to measure more than this, I think they just measure the light coming, the time taken by the light coming from there. That's fairly easy to do. But yeah, this is probably one of the older techniques. Okay. Estimation of very small size of molecules. I don't know what this is. This is not there in your textbook. Okay. All right. So there are again a lot of definitions. I want to get to the part where we can start solving things and all. But okay. Astronomical unit is defined as the distance between the sun and the earth. Astronomical unit. Light year, distance traveled by the light in vacuum in 1 year. In vacuum, speed of light changes according to the medium. In water it is different, in air it is different. Understood, no? So in vacuum we use that as the reference. Refractive index?
Refractive index comes to your speed of light.
Correct. Correct. So what is refractive index?
C by E.
Very good.
What's
Yeah, so refractive index is basically the ratio of the speed of light in vacuum, C, by V, the speed of light in that particular medium. It is just a way of, the reason the ratio is taken as, again, C is always going to be a constant. The speed of light in that particular medium is always going to be constant. So using this method, I can properly define a particular object. Example, if I have glass, I can say I want a material of refractive index 1.5, which corresponds to a particular type of glass. And anywhere I go in the world, this particular quantity is not going to change. The speed of light in glass is always going to be same. If I tell I want a particular material of refractive index 1/3, maybe it corresponds to water. Water is I think about 1.6 or something. For oil and all, it will be higher, it will be around 2. So anywhere I go around the world, I can tell, hey, give me a material of refractive index 2 and it should do the job for me. The quantity remains constant. We as human beings, we like dealing with constants. Okay? Fair? Okay. So we also know what is 1 ton? 1 ton, you must have heard,
lots of things.
not 100 kg.
Many amount of kg.
Medium?
Many amount of kg.
Many. How many amount of kgs? 1000. 1000 kgs is 1 ton. 100 kgs is called 1 quintal. You might have heard about 1 quintal. Okay. For very small measurements, we use something called atomic units. It refers to 1.66 10 to the power minus 27 kgs. Very small quantity. We know what one solar day is. One solar day, the amount of time that it takes to revolve around its own axis. 24 hours is one solar day. One solar year, 365 days. These are all definitions, man, so many definitions. One lunar year, the amount of time that the moon takes to go around the sun, it's 27.3 days. 3 days. Okay. But have you heard about something called the dark side of the moon and all? What is that?
It's the other side which is
So the thing is, the moon's rate of rotation, how much it rotates and how much it revolves is so in sync that, let's say my thumb is one side of the moon, my index finger is the back side of the moon, and this is the earth. So it always goes like this. Getting it? So from earth, what you will see? You will always see the thumb. Okay? It is going like this. You will not see the index finger. You will not see the back side of the moon. So that is one thing about the moon. We don't know. There are a lot of theories and things like that as well. revolves as in rotate, it rotates. It rotates like this, but it's rotating like this.
Whenever it rotates,
The rate of rotation and revolution are so in sync that we only see one side. This is happening, but it is happening like this. Getting the idea? Alright. Okay. So there are prefixes to our SI units. You can read this through. You probably know about these things. Is there in your textbook? This table and all. 10 to the power minus 1 is called deci. 10 to the power minus 2 is called centi. 10 to the power minus 3 milli. Milli, you scale, you use centimeter, the next comes is millimeter. 10 to the power minus 6, we jump from minus 3 to minus 6, okay. It's called micro, okay. So any quantity in between, we either write it in terms of milli or we write it in terms of micro. For example, I have something that is 10 to the power minus 4. How do I write this? I am going to write this 0.1 milli. Okay? Understanding? You can write it in terms of these two. Or I can write this as 100 micro. 10 to the power minus 6. The 0 thing is cancelled. 10 to the power minus 4. Okay? So you can go through this in your textbook. I hope to get over these definitions and quickly start with some interesting stuff. Okay. Nano is 10 to the power minus 9. You guys, have you heard of nano? Pico is 10 to the power minus 12. Femto is 10 to the power minus 15. Atto 10 to the power minus 18. So these both words are very near and dear to me because I work in this kind of a thing. I work in high energy laser physics where we work on creating light pulses which are 1 femtosecond long. So if you divide 1 second by 10 to the power 15 fractions, so it will be 1 by, what I get is that's very short duration of time, and that's how long my one laser pulse is going to be, very short. The reason we do this is, the idea is quite simple. If you take a camera, I want to image you, you should be moving slower than the light, right? Meaning light will come like this from the camera. It's taking your image and it's coming back to me. The light that is coming from you, that light which is traveling has to be faster than you. Otherwise it cannot capture you. Because by the time, if you are faster than the light, you would have moved or something would have happened and I will get a blurred image. So the light has to be faster or it has to be shorter. So what we do is we create light pulses which are very short. Reason being, in an atom and things like that, things happen and a lot of incredible things happen at a very small time scale. Okay? In an atomic system, a lot of crazy things happen at a very short time scale. If I excited, some crazy things happen, nuclear physics, and you must have heard about all the nuclear fission and things like that, right? Nuclear fusion, a lot of processes happen inside an atom, inside an atomic system, which happens very quickly. In order to study those systems, I must create pulses which are incredibly short in time. Clear? Okay. Doubt?
So you're playing with shutter speed so that you could increase the amount of duration capture.
In a way, but it's not very straightforward, because what we are doing is we are working with lasers.
You're not working with cameras.
We don't. Our cameras are called CCDs, charge coupled devices, and things like that. Our cameras cost, like we have a camera, it costs about 64 lakhs, and it's this small. It has to be cooled by liquid hydrogen, and it has to be kept in vacuum. If it is kept in air, it's gone. Operated in air. Such kind of cameras. Alright? Interesting stuff? Okay. So we can now finally, I hope, quickly move on to some interesting things. And okay, there are two definitions before that. One is that of, I don't follow this thing, okay, accuracy and so what is accuracy? What is precision? Accuracy is how close your measured value is to the actual value. How accurate you are. Maybe something is 5 meters long, I measured it as 4.5. Some mistake from my end, but it is, my accuracy is going to be how close it is to the real value. Okay, fine. Precision is, there is something 5 meters long, all four of us are measuring it. You got 4.5, you got 4.6, you got 4.7, I got 4.8. How close our values are to each other.
How close are different values to each other?
Measured by different people, regardless of what the true value actually is. Understood? So in such a case, if I want to take the measurement of the system, I don't know if it is 5 meters long. I don't know. So what I will do? Hello? Yes?
Your voice is low.
Can you hear me now? Accuracy, okay. So accuracy basically refers to how close a particular measurement is to the actual value. Can you hear me now?
Yes.
Okay. So if something is, let's say, 5 meters long and I measure it to be 4.7 meters. So the idea of accuracy is how close is my measured value, how close is it to the real value, the actual value. Understood? That is accuracy. Now precision is, let's say I have a particular thing which is 5 meters long, but I do not know if it is 5 meters long. I have no clue. So how do I find out? I have to take the measurement. So let's say we are 4 people are here and one guy measures it at 4.6 meters, one guy 4.7, another maybe 5.2 meters. It can go either way. So we measure that, and what we do is, in order to establish what is the length of that object, we take the mean. Mean means we will add it up and we will divide by the total number of readings. So if I have 5 readings, 5 number of readings I am going to add, divided by 5. I am going to get one value, and I am going to assume that that is my true value. Understood? So that this is called precision. How close are our readings to one another? Now we are measuring around 4.7, 5.1 range. One fellow is coming, he is measuring 6.2 meters. Is he precise? No. Understood?
So, sir, precision is the mean of different values.
Precision is how close are different values to one another. Closeness. Okay. Mean,
Accuracy is
how close is it to the true value, to the real value. Okay. Mean is when you want to assume a true value but you do not know the actual value. So what we do is, now for accuracy you know what the true value is, 5 meters, you knew it. But in case you do not know what the true value is, we are going to take the mean and we are going to assume that to be the true value. Clear? So if somebody's reading is very precise, does that mean it is accurate? Not necessarily. Correct. It might not be very close to the true value. We may take 4 readings, we may get 4.2 or something. The actual value is 5. That means we are all making mistakes.
So, precise value doesn't mean accurate value.
Not necessarily. Okay. Precise is what we have measured. We can measure anything. You know, it's like 5 people making biryani, it may go wrong. Doesn't mean it's very precise, it's not the real biryani, but it's not accurate. Getting the idea? Okay. So now we get into the idea of a very interesting topic, which is called errors. So The definition is quite straightforward. You take your true value and you subtract the measured value.
So
The difference is the error. Okay, given by delta E most often. Okay, it's just shown as delta E. Okay, so there are 4 types of errors that have been defined are here. You can read through them. The definition is quite straightforward. I want to show you the interesting part, because these definitions even you can read. See, the first one is systematic error, meaning the errors whose causes are known and therefore it can be minimized. I made one error. Okay, let's say something, I don't have good eyesight, but I am trying to measure it. So that is my systematic error. I know the cause. What is the cause of the error? My eyesight is not good. How can I fix it? I get somebody with good eyesight to measure it. Simple. Systematic error. Okay. Sometimes the instrument may be wrong. Some problem, some instrument, some issue with the instrument. It's also called systematic error. Okay. Some instrument, some error in the instrument. Then what I do? I know there is some error. Either I do something to compensate for it, or I get it fixed, or change the instrument. Something like that. Okay. Random errors for which the causes are not precisely known and can be minimized. So now what do? You have a random error. You don't know where is the error coming from. You are doing some sort of a measurement. It does not necessarily mean only measuring length. I am giving you that example from that time. It can be some very big experiment. You might be measuring the mass of the Milky Way galaxy or something like that. It can be something as simple as some kind of a graphic design you are doing. Some particular iteration is not coming right. So what do? It's random, and you don't know why there is an error. You don't know why there is an error in the experiment. So what do? One of the best ways is, if you do not know why it is coming, you make multiple people do it. You take a large number of samples and you take an average of it. Okay? If you do not know, if it's a random error. But if it is a systemic error, meaning there is an error in the system, then all the 5 times you do, that error is going to repeat. If your cycle is not working fine, even if you write it 5 times, it will not work fine. Just because you are doing it more number of times doesn't mean the problem is solved. So systematic error is, you know what the problem is. That's why you have to inspect and you have to figure it out and you have to fix it. Clear? Okay. So gross errors arise due to carelessness of the observer and hence can be minimized by taking an average of the reading. Even gross errors, what happens is, if I am careless, gross, GROSS. If I am careless, instead what we do is, I can take multiple readings and I can take the mean of it with the hope that I am less careless each time.
Sir, I don't understand the difference between systematic and gross.
Systematic is an error which is the error in the system, man. Like, it is something whose error you know.
We didn't do systematic.
Systematic, it can be you also, it can be instrument also, it can be, see, there are more things. Personal error, error due to the temperature, error of something, but you know what it is. So you can fix it. That is the thing about systematic. You know what it is, so you can fix it.
Whereas in gross error, we are knowing it wrong and we are doing it wrong.
You don't know what is the error. And the second one, see, second one is random errors. You don't know, it's random. Gross, maybe it is a problem of a person if I am being careless. System is perfect. My scale is there. My object is there. Everything is perfect. But I am making some mistake in reading. So what I can do? I take more number of readings. I add it up. I take the average. I divide by the total number of readings. I get the average. Because if I am careless the first time, maybe the second and third time it will be better. The fourth time it will be better. Fifth time I am doing it, I will be better. Getting it? The more number of times I do it, maybe I'll do better.
The more accurate.
The more accurate I may be. Clear? And there is something called least count error. That time we discussed what is the least count of a scale. The least count amount it can measure of our scale. What is it?
0.1 millimeter.
1 millimeter. That's the minimum quantity that can be measured. So instead of if you are measuring something, it lies between 0.1 and 0.2. What are you going to do? You will not measure. No, now you have only scale. It is coming between those two lines. You are understanding?
0.2
Okay, and okay, I have one toy car. I want to measure its length. Okay, let's say I take a grain of sand. That's better for this example. Grain of sand. I want to measure its width. Okay, I'll start from here. In my scale, it is coming between 2 millimeter scales. Or if I take a car, I'm highlighting it. If I take a toy car, let's say, I have a toy car. Okay, I'm measuring it. So this is coming proper. It is coming till let's say 33 centimeter, and then there are smaller divisions. No, so this part, no, it's coming between 33.1 and 33.2. So what will you take it?
It's coming between.
The edge is coming between the two. You want to measure I want to measure the length of the toy. So I got it. Okay, this 33, but the exact measurement is between 33.1 and 33.2.
33.15.
See, the thing is, you cannot measure it because your idea is that the smallest measurement that's possible is 1 millimeter. So I cannot measure that something that lies between it. So
that's the least count.
the least count is the least amount that the thing can measure. I cannot measure less than 1 millimeter. It's lying between 1 millimeter. It's smaller than 1 millimeter. I cannot say if it is 33.15, 33.17. I don't know.
So we can't.
We cannot. So we will assume some value. We do that all the time. We write as 33.1. I'll write as 33.2. But is that correct? It's not. It's not very accurate. This error is called least count error. This is another type of error. Understood? Clear? Not everything is accurate to 100%. We cannot do that. You see, you have been using your Kamlinka scale from childhood. How exactly do you know that 1 centimeter is the real 1 centimeter? You know, in labs we are not allowed to use these scales. We are in labs. We don't use these scales and all.
Only when you
Not only 1 year, yeah, scales of that sort, proper ones, not plastic manufactured by somebody. If it becomes little hot, the plastic will expand. Your 1 centimeter will be 1.01 centimeters. It will not be accurate. Understood? So the thing is, okay. So now comes the interesting thing. All right. So, So what is our error? What did we say was our error?
least count.
No. Error ka definition?
True value minus measured value.
True value minus
Measured value.
my measured value. This is my error. Okay, and this is often called absolute error. Okay, so but there are cases now wherein, so what I can also do is, okay, in your textbook they have called it delta A. I don't know why, but let's go with that. Okay, delta A. All right. So what I can do is now, for example, I have, but why? Okay, fine. I have an object, okay, and it has a particular true value. Okay. Now I have taken 5 readings: A1, A2, A3, A4, A5. Okay. I want to know what is the error. So what I do, first I will find delta A1. Meaning, see, if this is 5 meters, let's say, is the true value of one object. This has been 4.2 meters. So what will be my error? 5 minus 4.2. Okay, 0.8. Similarly, I am doing for all. So every measurement I am taking the error. So now I want what is the something called the not absolute error. Each of this is an absolute error. But now what is the, so see, if I take different readings, what do I do when I take multiple readings? I take the average. It's called the mean. Okay, so I take the mean of that. So similarly, I do the same thing for the error. I am going to take the mean of the error. So this kind of, so what, see, do you know this sigma connotation? Summation. I take the sum of all of that and I divide it by total number. And this particular value, I call it the mean absolute error. Is this much clear to you? Alright. So if my error is, if my true value is 5 meter and my error, mean absolute error or whatever, my final error is 0.03 meter. So this means that the range of measurement is happening between 4.97 meters to 5.03. What did I say?
So here 4.9 something, it is the measured value.
If this is the actual value, this is my error. Final I have found my error is 0.03 meters. Meaning that my total measurement, till now what I have measured, its range is lying between 5 minus 0.03 to 5 plus 0.03. In this range, I am taking my readings, I am getting in this range. Clear? Very clear? Okay, I hope so. So, now very simply, what I do is, there is something called relative error. What I do is, I take the mean absolute error and I divide it by my mean value. Meaning, in the previous case, this would have been 0.03, which is the error, the mean of the error, divided by the absolute value. In this case, let's take it as 5 meter. True value or the average of the mean. See, if I know the measurement of an object, that is my true value. If I know what is the true value. If I don't know what is the true value, what I will do? I will take multiple readings and I will take the mean. That is taken as my true value. Why? Because I don't know what is the true value. If I know it, I use that. If I don't know it, the mean is that. Is that clear? Okay. Fine. And if this is called relative error, and then if I multiply this into 100, it's called percentage error. Okay, my handwriting is very bad, please forgive me. Is that clear? Okay, so on this note, okay, on this note, do a problem. Can you solve a problem? You can always ask me to go back to the previous slides to show you the formulae if you want. Okay, but I hope you would have understood the concept. Okay, note this down. In an experiment, the refractive index of water was observed to be see I'm writing the values on the board. It was observed to be these values. Okay, I'm writing it so that you don't make a mistake. Write these values. So these are all the values, all the measurements. Yeah, put comma between them. I did not put comma because I don't want you to confuse between the dot and the comma. If I write continuously, so I added some space. Okay, have you write all these values down? Okay, calculate the mean value the mean absolute error, calculate the mean value, the mean absolute error, the relative error and percentage error in the value of refractive index.
Mean absolute error.
1 minute. Calculate the mean value, the mean absolute error, the relative error and the percentage error in value of refractive index. I repeat, calculate the mean value, the mean absolute error, the relative error and percentage error in the value of refractive index.
What is the true?
It's not given. So what do you do? How? If you do not know the value of something, what do? We take multiple measurements and we get the mean. So your mean is going to act like your true value. So first thing that there was, calculate the mean. If you know the true value, it's fine. Okay, but you don't know, so calculate the mean. Anybody got an answer?
It is
1.33.
1.3.
Okay, take it as 1.33. This will help us in other calculations. Okay, that is the actual value. You must have done some approximation in your calculation. Okay, this way we will know if things are right. We can always cross check. I can cross check. Okay, did you guys get it? But you understood what to do, right? You understood, right? Then just write the mean value as 1.33. You understood, right? You are adding and you are dividing by total number. Fine. Just write it as 1.33. Okay, so now what do we find out after the mean value?
Mean absolute error.
So what is that? mean of
Value minus
ah
the state value and we add it up and find the mean.
correct. So you for now what do you have to do? You know your so for each of these values you are going to find the error of all of these. Do it. True value minus measured value. For each you have to do. Can you write it in a nice way, like orderly way where because you're going to have many calculations, right? Do it in a way that you
This is perfect. We have 1.3, so it is better than 0.
1 point.
We have 1.3.
So that your error will be 0.
But that does come under count as when we take the mean. But that does come under the count when we take.
Yes. When you take the mean, that comes under consideration. All your values.
Now we have what values larger than our mean. So
It will be minus or plus. The signs will come. But when you're taking the mean, you are going to add a modulus, which means, see, don't take the sign. Now you write it as minus whatever you get or plus whatever you get. You write it that. But when you're taking the mean, you're going to take the mod of all. So the minus will go away and it will only be plus. Ananya, are you able to follow?
Yes, sir.
Okay, wonderful.
Sir, I have a small doubt.
Yeah, please tell me.
It's not related to the question, but
Could you repeat? Could you come again? I'm not able to hear you well.
no, it's not related to the question.
Okay.
But then, if I have any doubt when I'm doing on paper,
Hmm.
where do I go? Which number should I contact?
I can give you my number. You can always contact me, or you can, if they have given you number of the academy, somebody to contact, you can contact them as well. Or if you have some doubt when I'm teaching you, you can always stop me like this. You can ask me. So whatever you prefer, that can be done. If you want my number, I can give that as well. Okay. In fact, I think it will help if we all make a WhatsApp group together with all the students, so we can have some discussions there, or if anybody has a doubt, you can put it up there. I'll put my number in the slide here, you can note it down, make a group. (819-768-1255). Okay. So, did you guys get the values?
Sir, excuse me, sir.
Yes.
For mean absolute error,
Yes.
we will add.
You will add all of these, and the problem is there are minus signs in some. No. That's okay. That's good that you have not taken the minus into consideration.
No, we should not.
Don't take it into consideration. We take the mod of this. So the minus is not being taken into consideration. You just add them and you divide, and what is the
Divide by the
number of this thing? But your value, you have gotten something wrong. You know,
What is the 0.0025?
0.0.
0.25.
Yeah,
Correct.
0.025.
So we have to take the minus of value. Only if we get the negative value, the final stage we have to take the modulus.
Yeah. Final stage you're taking the modulus.
Yeah, I took the modulus in the final stage, but derivation value, that the mean value we added itself is positive only.
You have not divided it by 8, no, but
I did.
0.02 divided by 8.
Complex.
Okay. So this is only possible when you are taking the minus signs also as well, is it?
22.
Then they have made a mistake here.
But when you take it in your case, if we get the final value after we add, when we get the minus value in the final addition itself, then we get weighted modulus.
1 minute. Let me just check with what they have done here, because these things are important. Otherwise, if they have made a mistake, no. Let me just tally things out. No, you do not take the modulus. You do not consider the signs. You add them up regardless of the sign, and then you divide it by 8. You have been lucky that you got the same answer.
So is it 0?
So what we are gonna do is 1 minute. See, what was your first value? 1 minute. You tell me what was your first value with the sign. With the sign.
Plus 0. Plus 0.
Okay, so I'm going to take 0.04. Next one.
Plus 0.0.
Okay, plus.
Minus 0.01.
But I take the mod, so I'm going to make it plus. So what is going to be?
0.0.
Okay, plus 0.0.
2.
Okay.
Plus 0.01. Plus 0.03. Plus 0.03.
Again, huh?
Yeah.
Okay.
Plus 0.06.
Okay. Divided by 8, no? One minute. See, 0.00, 0.0. Okay, good. And then what you do is you can. I think they have made one mistake here. It's or. Maybe you guys have made an error. Okay, so when you actually solve this, if you 0.0175,
So maybe they just rounded off.
they can round it off to 0.02. This is what you get. This much you understand?
14 by 8. Okay. Yeah.
This part I'll show you in the next class. This is called rounding off. Okay, this will be taught in the next class, some basic stuff. Okay, so now I have what value did I get?
Absolutely.
My mean absolute error. But there's something they are also asking, what is that thing called? Relative error. So what is my relative error?
My mean absolute error by
Divided by
mean value.
Mean value or actual value, true value. Here we don't have true value, so we are taking the mean value. Divide. And 0 point?
No, I'm asking mean absolute error divided by mean error.
Not mean error.
Mean value.
Mean value. It should actually be true value. Okay. Ratio of error divided by true value.
0.14 by 1.3.
Correct. Okay. And last one. Okay, you just do this.
So it's like this.
Yeah,
Mean
come.
absolute error is 0.02. 0.1. 0.1. 0.1.
0.1 minute. What? I think you guys are talking about two different things. What are you talking about?
I'm talking about the relative error.
You're talking about the relative error. He's asking about something else.
No, sir, you said we need to round it off 0.
You may or you may not. They have rounded it off. And what is rounding off? I'll teach you in the next class. If you want, you can just note it as 0.02. What is this? I'll teach you in next class. This concept is there. We are going to learn about it. 0.015, something like that. Okay, no problem. Doesn't matter. They're okay. And now the last thing they've asked us to find is, so what we do? We chumma multiply it into 100. That's all. So we get a percentage. So it will become 1.15.
10.5%.
Not going to be 10.15. It's going to be 1.5.
No, it's 0.105.
Yeah, 0.015.
0.105.
0.105 is what you're getting. Then it will be 10.5. Fine. See, the thing is, you're doing very fine calculations. No, and that too by pen and paper. Some errors will be there. So the thing is, you will not always get the same answer that he is getting. But your faculty, they will have a range of values that is acceptable. So as long as it's around that range, it's fine. Because we understand you're not using calculators. But that still means you have to be good at what you do. Okay. So with this, for now, we'll be done. Some interesting things tomorrow is our next class, right? Tomorrow we will continue. This topic, unfortunately, this unit is a slightly boring one, slightly more theoretical. But hopefully from the next unit, we'll have many interesting things to discuss. Okay. So, how's the class? Was it fine? Any reviews? Teaching is fine? Anything to be improved? You can tell me on my face. Huh?
Sometimes your voice goes a little bit low, so I can't hear.
Okay, you can't hear me properly because I'm speaking low. Ananya, we're done with the class today, okay? I'll see you in the next class. If you have any doubts, you can let me know. You can note my number. Somebody make a group, no? Make a group. Do you have their numbers to make a group? Okay, Ananya. See you. Is that fine? Mean absolute error. It's in the name. All my errors, I'm going to take to mean. So it's going to be, you can write it in how you understand. If you understand the language of what is that sigma summation, you can write it as summation, delta E, down here to an I. So let's say we can write it like this. Summation my delta error. How many errors I have? I have I number of errors. So first one will be delta 1, delta 2, delta 3. So my I will be there. My I will go from 1 to, let's say, n. I have n number divided by n. That is the mean. Here? Everything was fine today, right? Yes. Teaching is all right. Yeah. See, and my main objective is for me to deliver the concept. Problems you can also solve once you have understood the concept. My main aim is for you to understand what the concept really is. So I generally do conceptual teaching if I do teaching at all. And my expectation is problems will be 1 or 2 I can solve, but everything if I want to solve, the whole class doesn't solve this problem. But if you have understood the concept, you can solve any problem. Clear? So it's a 50-50. You guys also should work on things by yourself. So Balaji, what do you want to do in the training and they are learning on things.
Like conditionally doing like a hybrid degree. One main degree would be mechanical engineering. So they say complete data science.
Yeah, but you can always do mechanical engineering and then get into data science. My husband actually did the same thing. He did his bachelor's in mechanical engineering. Later on, he did his master's in data science, and now he actually works in data science. Sure. Engineering basically is when you find out what you really want to do.
Already training.
But my info you would be going to go to college. Okay. No matter how good you are with your craft now, if nobody knows who you are, nobody knows how you are. If you are the best